Hello students, welcome to Saurav Sir's classes. The first question is, let x1 up to xn be a random sample from a uniform 0, theta distribution such that theta greater than 0. Let t1 is equal to 2 by n summation xi and t2 is equal to maximum of x1 to xn. Then which of the following is not a correct statement? Option A, T1 is method of moments estimator and T2 is a maximum likelihood estimator of theta. Well, if we want to calculate the methods of moment estimator, that is, what is the mean of this u0, theta? That would be theta by 2 is equal to, since it is equal to x bar is equal to summation xi by n. So using these two, we can write theta is equal to 2 summation xi by n. Thus T1 is the method of moments estimator. The likelihood function can be written as pi I is equal to 1 to n 1 by theta is equal to 1 by theta to the power n. Now for this to be maximum, theta needs to be maximum of x1 to xn. Thus T2 is the maximum likelihood estimator of theta. Now option B, both T1 and T2 are consistent estimators of theta. Well, this is true. T1 and T2 over here are both consistent estimators of theta. Now, so option A is true, option B is true. Now let's analyze option C. Both T1 and T2 are unbiased estimators of theta. Expectation T1 is equal to 2 by n expectation summation xi, which is 2 by n summation theta by 2, that is 2 by n into n theta by 2, which comes out to be theta. Therefore, T is unbiased estimator of theta. Now I'll erase this rough work because I need to do more. So I will be requiring a lot more space. Now let us calculate the cumulative distribution function of x, that is probability xi less than equal to x, which comes out to be x by theta for all I. Probability that t2 less than equal to x is equal to probability maximum x1 up to xn less than equal to x. So probability x1 less than equal to x, x2 less than equal to x, xn less than equal to x is equal to pi I is equal to 1 from n. All the xi's are less than equal to x, which gives us x by theta whole to the power n, and probability that t2 is equal to x is written as n x to the power n minus 1 by theta to the power n. Thus, expectation T2 can be calculated as, we'll just remove the space. Expectation T2 is equal to summation 0 to theta x to the power x into n x to the power n minus 1 by theta to the power n is equal to n by theta to the power n xn x to the power n dx, which gives us n by theta to the power n x to the power n plus 1 by n plus 1 theta 0 is equal to n plus 1 theta to the power n into theta to the power n plus 1, which gives us n theta by n plus 1, which is not equal to theta. Therefore, T2 is not an unbiased estimator of theta. So this statement is false because T1 is an unbiased estimator but T2 isn't. So option C is the correct option.